so today we're down to here. We're going to do chapters 7 and 8. And I've got them ready to go here. Let me make this the right size. Okay, and we'll start with chapter 7 and reconnect and just run these blocks from the start. Okay, all right. So this is the one that prepares it all. All right, so iteration and search. You have loops. You can have for I in range of 3, print I, and you can put an end statement in your print statement. It just says what it's going to do after printing each of these. So instead of putting each number on a separate line, it'll just line them up this way, putting a space after each one instead of a carriage return. Here, for each letter in Gadsby, print the letter N, so that'll just print them out like that. And, all right. And so, by the way, if you're going to do this, it's considered a good practice to change the variable to something more descriptive, like letter. That's what they call self-documenting code. If you use descriptive variable names, it's easier for people to understand your code. And so here for letter in Gadsby, now we're going to try and find how many words begin with have an E in it. So if the letter equals E, or capital E or small e, then it'll print this word has an E. And it'll then print nothing. Now they're going to put it in a function, has E. One thing I wonder is if you had a word with 2 E's, it's going to print it twice the way this is going. And then they make a pure function that's going to return true. This will not just give you a multiple printing. This will return true if it finds an E in there and false if it doesn't. So it'll only find the first E and then return. It won't worry about future E's. So that's fine. And you can then have it not always use Gadsby, but just has word as a parameter. And now you've got a fairly useful function. So you can check to see if this word has E's and it doesn't. If this word has E's, and it does. So that works. Now they've got a word list of common words. And I didn't know you could do this in Python. You can download. I was doing it with bang wget. Anyway, this will download a list of 114,000 words. This will print it, opening it, and creating a file object to point to it. And then you can do readLine. Notice that it's a method attached to the file object. So instead of calling readLine parentheses file object, which might be more obvious, it's a method attached to a file object. So you have to put the name of the object first and a dot and then the method. So this will read the line from it, and the first line is AA followed by a carriage return, a new line, technically. And now you can... This just does the same thing. This saves it in a variable called line, so you can work with it, and then prints it out. And then we have these extra carriage returns at the end, and that's a little strange. So you might want to use strip to get rid of it. And once again, that's a method of a string object. So you put the name of the function after the object instead of before. And so will strip white space out from the front and end of something, things like tabs, spaces, and carriage returns and line feeds. So now you get just the word. Now, I'm surprised they did this one. This is going to take every single word and print it, which is 114,000 words. So, but Python is pretty fast, so there they are. Those are the end of the alphabet. And if you click in there and scroll back, you're going to get all of them. All 114,000 are in this little pane. So there they are. I would have just printed like the first 100 or something. But anyway, all right. So that's how you manipulate words and files in simple cases. If you make a variable here, x equals 5, Python will decide that it's an integer. And if I print type of x, it'll tell you it's an integer, all right? So it determines the type by the data you put in there, and you can reassign it. X equals 7, now it's 7. So you can modify it. And, you know, they make a state diagram. It was 5, now it's 7. We should be used to that sort of thing. And you can also do x equals x plus 1. That'll take the 7, add 1, and x will now be 8. This is very common. And I remember when I first learned computer programming, they pointed out that mathematicians are baffled by this statement. If you think of that as a normal equality, that's an impossible condition which is never true for any value of x. So you have to understand the equal sign does not mean the same thing it does to a mathematician. And some languages have the equal sign replaced by an arrow going to the left. It means take this value and assign it to that variable. It doesn't mean that it's an equation you're going to solve for x or anything like that. So now you can try to update a variable. It doesn't exist. Z is not defined, so that's no good, but you could initialize it. and then you can update it, of course. All right. So this is an increment, adding 1 to a variable. Decreasing it is called a decrement, and you can use plus equals to add to it. This is a shortcut. Z plus equals 2 is the same as Z equals Z plus 2. So it's 1. After that, it's going to be 3. All right. And so here we're going to count the number of words in the list. We're going to open the words, and I don't know why we're bothering to strip them. It doesn't really make any sense to strip them. It doesn't hurt anything, but it's a waste of CPU cycles at this point. Then we're going to add 1 for each one we have. So we'll get the number of how many words there are in the total, and that's 113,000 and change. You can have a second counter to count the words that contain an E. So now we can add this, and then if it has E, add that other one. So we have total and count. Now we get count. We have total up there, so we can get a percentage. Count over total times 100. All right. All right, and then another thing is useful is the in operator. This could have saved us a lot of bother. E in word is just going to see if this letter is in that word. It'll be a Boolean that's either true or false, and now it's going to be false. So you can write this, has E. If E in word or E in word, return true, else return false. And this works, but it is kind of unnecessarily complicated because this is a Boolean quantity, and this is a Boolean quantity. So we could just return that. We don't need to have the if and return true. We can just return this. That quantity is true or false, and that's the thing we want to return. So we only need one command here to do it. And by the way, another way to do it, instead of checking for both capital and lowercase e, would be to use lowercase, and then you can just see if the lowercase version of it contains a lowercase e. That's another way to do it. And I don't know which of those would be more efficient. It would depend on how fast this lowercase transmission is compared to another comparison if you really want to worry about CPU cycles down at that level. But nothing we're doing here is all that sensitive for time, not right now. Anyway, so now you can have use as any, where it's going to have words here and letters there. And now it's going to go through that list of letters and see if any of those letters are found in the word, and if so, return true. Otherwise, return false. So banana, and A is in banana, so it will be true. But I forgot to define it. Let me run this to define it. There. Now it's going to be true. And this apple doesn't contain any X, Y, or Z, so that's going to be false. All right. And it converts both of them to lowercase, so it doesn't have to worry about capitalization, which is good. All right. And here's something kind of cute. You can put unit tests in your code. I've never done this, but it's a good idea. You can have this kind of thing with the 3 greater than signs. You can have things that should be executed and the right answer, and then you can run these unit tests in an automated way with this thing called doc test. Run doc test examples. In professional coding, this is a really important thing. You write code and then you write unit tests that verify that your code works. This is real important, both for consistency and to make projects reliable, and also because you're going to be updating code. And every time you update it, you should run the unit test to make sure you haven't broken anything. So you should have enough tests to verify the basic functionality of your method. All right. And so this is the way you do it. It does use some things we haven't talked yet about global and this underscore, underscore name, underscore, underscore. But we'll talk about them later. Okay, that'll run the doc tests. And if it works, you get no output. If you want to, if we make an incorrect version, let's see what's wrong with this one. If letter in word letter, if letter in letter, return true. Oh, wait, no. This is incorrect. Return true, else return false. Oh, yes, I see the problem. If you go back here, the return false only happens after you've gone through the whole loop. It's not indented. So you check every word, and only if none of them are true do you return false. But because this one is indented, if the first letter is not there, it'll return false and never look further. So that's the incorrect thing. So if you define this one and then run the doc tests, it'll tell you this failed. It tried to find A, E, I, O, U of banana, expected true, but got false. Now actually, I'm confused. Oh, they're just comparing the letters one by one. No, for letter in word lower. Oh, it goes through this word letter by letter, not that way. I would have done it. Okay. So it takes the B in banana and looks to see if it's matching a letter. And when it doesn't match the only thing it does is look at the first character in word and the first character in letter. That's the only thing it actually looks at. It considers this false. Anyway, all right. So that's the Chapter 7 stuff. The loops are very important. And those Boolean things are very important to know. All right, let me stop this one.